Hey guys, welcome back to Science. We are continuing investigating how humans use patterns to communicate by sending and receiving codes. In the last lesson, you guys read about how humans used patterns to communicate, and we found all these different methods of communication. Today, we're just going to look at digital devices and binary code with ones and zeros. Codes just mean a pattern of symbols. But today, we're just going to look at binary codes and how those binary codes can help us communicate information across long distances. So even this is a code. This shape tells me that it's the letter O, and the letter O tells me that it makes a certain sound. So I can see this and understand that I would say the word 1. Believe it or not, all digital devices use a code that involves patterns of just two numbers, 0 and 1. This code is called binary code, and people use it to program these devices to perform specific actions. Patterns of zeros and ones serve as instructions for digital devices. Every time you type a message, your device converts each letter into binary code and sends that code to another device. The other device recognizes the code and displays the letters of your message to the person receiving it. Similarly, when you talk on a cell phone, your phone uses binary code to convert your voice to binary form and send it. Your friend's phone converts that binary signal back into sound so your friend can hear it. We understand messages that are written with the letters of the alphabet, but digital devices understand messages that are in binary code. Do you guys remember that activity we tried last time with me and my husband, and I tried to describe to him the image to draw? We're going to try to do that again, but instead of my descriptions, this time we're going to try using binary code and see if that helps improve the accuracy of our drawing. So I'm going to give zeros and ones. I'm going to talk in binary, and he's going to try to decode my message. That means he's going to translate it from binary code into an image. So here's the code we're going to use. If I say a 1, that means he's going to color in that space black. If I say 0, he's going to leave it blank. And we're going to start from the top left square, and we're going to go from left to right and top to bottom. So let's hope that this is better than last time. Okay, here we go. So, are you ready? Okay. 0, 0, 1, 0, 1, 0, 0. 0, 0, 1, 0, 1, 0, 0. 0, 0, 1, 0, 1, 0, 0. 1, 0, 0, 0, 0, 0, 1. 0, 1, 0, 0, 0, 1, 0. 0, 0, 1, 1, 1, 0, 0. 0, 0, 0, 0, 0, 0, 0. Okay, look, he got the exact picture. So this is exactly what I had drawn. When I tried to describe it, it did not turn out right. But now that we used binary code, we were able to get an accurate image. Now, two important vocabulary words we need to know. Encode means we're going to turn information, such as an image like we just did, words or a sound, into code. And decode is the opposite. It means we're going to turn the code into information that we can understand. So I'm going to show you how this works using an app called the Code Communicator. And we're going to make a new image, and this is going to help us encode an image and turn it into binary. So we're going to click encode. We're going to click black and white image, large, and we're going to click new. So I need to make a new image. Maybe I'll make the letter H for Higgins. All right, I made my image. Now we can click this box at the top that says show binary. And I just encoded an image. I turned a picture into a string of code. So now I would need to write this down. My picture is now 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 0, etc. So let me jot that down on my sheet here so I know what this looks like. I'm going to color it and record the code. 1, 2, 3, 4, high, Oops. Okay, and then I'm going to put in the code as well. So this would be 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so we just encoded an image. I started with a picture. Now I've turned it into a string of zeros and ones. Digital devices use this binary code to send images, text, sound, such as voices, and even movies. Information that has been changed into binary code is called digitized information. So this code here that we just made is called digitized information. Before digitized information, messages could only travel so far before degrading or breaking down. For instance, a sound signal can be loud, but there's still a limit on how far that sound can travel. With digital devices, humans can now send messages to someone halfway around the world with the click of a button, and that message will arrive looking or sounding exactly as intended. So in a noisy classroom, if we were doing this activity with everybody at once and everybody's trying to yell across the room, 0, 1, 0, 1, it would be really difficult to do. Can you think of an easier way that we could use binary code to send a message across the room? I'm thinking that maybe instead of yelling the zeros and ones, maybe we could show hand signals and put a one finger up or make a 0 with our hands. And then our partner can see the 0 or 1 and we don't have to all scream across the room. That's one way that we could use binary code to send messages across long distances without it breaking down. And we would be sending it accurately. Okay. For today, I really want you to try this with someone at home. The blank grid is attached, and I really want you to play with this Code Communicator app. So you can make your own image, or if we want to go back, you can also decode images. It's really fun. This is a material, not an assignment, so there's nothing that you have to turn in, but I do really want you to have fun with this. So play around, have fun. And then we have one more science lesson next time. So I will see you then. Good luck and happy working.